system, we have our two groups of organs. Okay, so again, this is completely wrong. The GI tract is down here. All right, so this is what we call the GI tract. Okay, GI tract is stomach and intestines. Now the entire thing is called the alimentary tract. Alimentary tract. All right, so the alimentary tract, or the digestive system, all right, we start with the oral cavity, and then we have the pharynx, the esophagus, stomach, small intestine, large intestine. Okay, so all of these are the alimentary tract, or the digestive tract, but the GI tract is only the stomach and the intestines. Okay, so that's something that we want to clarify and make sure you guys have that down. Okay, so GI tract is specifically stomach, small intestine, large intestine. All right, now, along with the alimentary tract organs, we have the accessory digestive organs. Now, accessory organs would be like the tongue and the teeth and the salivary glands. Okay, so tongue, the teeth, the salivary glands, these are all accessory organs. They help with digestion and metabolism of the foods. And then down here we have the liver, we have the gallbladder, and then we have the pancreas. All right, so these are all of our accessory organs. So they help with digestion, they help with metabolism of what we ingest. Now, we talked about this way back at the beginning of class, but when you eat something, all right, so something's in your mouth, or something's in your stomach, or something's in your intestines, is it actually in you? Molly, wait. Not until it's digested. And what's the next step? Okay, so digestion is just breaking it down, but it's not in you until what happens? All right, so you're right. You remember what's the next step? All right, it goes into your bloodstream. We call that absorption. All right, so when we look at the food and the food material is not actually in us until it's absorbed and then metabolized by the body. Okay? So we're going to talk about that and how that relates and why that might be significant. All right, so here's the alimentary tract, the hollow tube from mouth to anus. Now, the primary functions here of the alimentary tract are, number one, digest the food, number two, absorb the food. Now, digestion is a breakdown process. And if we remember this from back in the first day of class, we talked about breaking things down, and we call those catabolism or catabolic reactions. Now, building things up are called what? Anabolic. Okay, again, so they think of anabolic steroids, they build muscle, so anabolic means building things up. Now, step 3 is ridding the body of undigestible waste. Okay? Now, this isn't from your cells. This isn't metabolic waste. This is just undigestible foodstuffs. All right, so we think about defecation. All we're doing is eliminating the alimentary tract from what we can't absorb. Now, the accessory organs help with digestion, and they help with metabolism. Okay, so metabolism is how we process the foodstuffs. All right, the big one here is the liver. All right, so your liver is the largest visceral organ, right? The largest visceral organ in your body, and it's responsible for metabolizing everything that we absorb through our alimentary tract. So we'll talk about that more towards the end of the lecture. All right, now, when we look at the steps or the events of digestion, all right, so the first event is when you take some food and you put it in your mouth. All right, so we call that ingestion. So you ingest some food. Now, ingestion is a voluntary process, right? You choose. Right? Maybe not so much when you're like an infant. An infant, you pretty much just, you eat whatever is given to you, right? But as you get older, then you choose what you want to eat. Okay, so the 2-year-old doesn't want to eat those Cheerios. What happens to those Cheerios? All over the place, right? Just throw them everywhere. And if you have a dog, that's even better because then you just throw them down to the dog. Now, mechanical digestion takes place as soon as we put food in the mouth. Okay, we talk about this as mastication. Okay, so mastication is chewing. Okay, so mastication is chewing. Now, your oral cavity is designed for the mastication process. Mastication tears the food into small pieces, right, using your teeth. And then, at the same time, your tongue helps to mix the food with saliva, and that initiates chemical digestion. Okay, now both of these are important, and they both happen together. All right, so they both happen simultaneously. So as soon as you put something in your mouth, you start to salivate. Now, saliva contains enzymes and water, right? Mostly water, 99% water. But it does contain enzymes that mix with the food and immediately begins chemical digestion. Now, mechanical digestion, again, is extremely important because it tears apart the food, increasing the surface area so that chemical digestion can work better. All right, so again, it increases the surface area so chemical digestion can work better. Now, if you don't chew it, it's not going to get digested, right? Okay. You guys have a dog? Ever have a dog? Yeah. So when your dog swallows something whole, it usually comes out the other end whole, right? Very little digestion occurs unless we chew our food. Now, when we look at chemical digestion, water is a solvent. All right. So water does help to break down your food to a certain degree. But then we have all kinds of enzymes. We have lots and lots of enzymes in our saliva, in our stomach, in our small intestine. And enzymatic breakdown is called hydrolysis. Okay, so hydrolysis is the breakdown of food through enzymes. And so enzymatic breakdown of food is imperative, especially for protein digestion. Okay, proteins are typically very, very large molecules. And for our body to absorb them, they have to be broken down into amino acids. Okay, so you guys remember this from way back at the beginning of the class. Proteins are made from the building blocks amino acids. And those are the ones that we can actually absorb through the lining of our alimentary tract. And so we need lots of enzymes to help break down our food, especially proteins. Now, once we break down the food into the smallest particle, then we can absorb the nutrients through the lining of our small intestine or through the different areas of our alimentary tract. Now, at the very end of things, we have this process, defecation, which eliminates undigestible food from the body. Now, propulsion is a separate event. Okay, this is not necessarily an event of digestion, but it is a very unique process that we see along the alimentary tract. Now, the propulsion from one place to the next is done through a very unique movement known as peristalsis. Okay, so peristalsis helps to propel food. From one place to the other. Okay, so we have this unique, specialized contraction called peristalsis that pushes the food from one point into the next. Now, the easiest way to understand peristalsis is think about swallowing. All right, so swallowing is referred to as deglutition. Okay, that's like the fancy term for swallowing. But when you swallow, you can feel it go from the back of your throat, and you can kind of feel it go all the way down into your stomach. Okay, so it's a wave-like contraction that propels food or liquid from one point until the next. Now, we see peristalsis in other parts of our body. We see it in the urinary and reproductive systems as well. But for the most part, the peristaltic activity is used extensively through the digestive system. All right, so these are the different events. You guys have any questions on those? Not so much yet? All right, did you guys all practice ingestion today? Abby, did you have a good breakfast?
No.
Did you eat any breakfast?
No.
No? Man. All right. Now, when we look at the control and regulation, okay, digestion is controlled and regulated through the parasympathetic nervous system. All right, so you got your parasympathetic nervous system, PSNS. Now, the parasympathetic nervous system reaches out to all of our internal organs. Now, the part that specifically reaches out to the digestive system is called the enteric nervous system. Okay, so this is the one that directly innervates the gastrointestinal tract, plus the esophagus. All right, so basically from your esophagus to the anus, the parasympathetic nervous system innervates that section or those sections. And again, we call that specific part the enteric nervous system. Now this controls all of the glandular secretions and movements and hormone release. Okay, the parasympathetic nervous system secretes a number of different hormones that help to control and regulate what goes on here in your digestive tract. Now, when we look at the parasympathetic nervous system, okay, the parasympathetic nervous system is primarily reflex, right? Now this was proven, right? This was proven through the studies done by Pavlov and his dogs, right? So he would condition them to expect food when he rang a little bell. So he'd ring a little bell and feed the dogs. And then the dogs would eat, you know, and he did that for a while, and then he'd ring a bell and he wouldn't do anything. And he would watch the visceral reactions of the dog, right? The dog would be expecting food. The dog would start salivating, okay? And that's a reflex action initiated through the parasympathetic nervous system. Now, another example of that reflex is swallowing, right? Is that peristaltic wave. Now, do you voluntarily initiate the peristaltic wave, or does it happen all by itself? What do you think, Morgan? It just happens, right? What about the churning of your stomach? Does it just happen? It just happens, right? The churning just happens. You don't think about it. It's not like, okay, hold on. Got to take a break. You got to churn some food now. Okay? It's not like you have to do that. It happens automatically. It's a reflex. And so, when we look at reflexes, and if you guys remember this a little bit, we had this on a quiz, all right, in regards to the nervous system. Receptors are what initiate a reflex, right? So we have these receptors that initiate these reflex actions of your digestive system. Now these receptors are sensitive to chemicals, and they're sensitive to stretching or distension of your different parts. Okay, so think about a chemical receptor that you might have in your oral cavity. What do you think, Molly? Okay, so what's a chemical receptor you have in your mouth? Chemicals? Nothing? What do you think, Jess? Well, that's a gland. What's a receptor? Chemical receptor. On the surface of your tongue. All right, taste buds. Okay, so we have these receptors. Taste buds taste buds are a great example of these chemical receptors. And as soon as you put something in your mouth that has any type of taste, any type of chemical in it, all right, you immediately start to stimulate the actions that we see here of the enteric nervous system. All right, you immediately start to salivate. Okay, so even if it doesn't taste very good, you start salivating, right? Now, when your esophagus stretches, all right, so that's a stretch or that's a distension. And your esophagus immediately contracts and creates a peristaltic wave. Okay? Or when your stomach stretches out, you start to churn. Your stomach starts to churn and grind up the food, mixing it with acid and enzymes. All right, so the receptors are located in the walls of the alimentary tract organs, and again, sensitive to chemicals and distension or stretching. Okay. Yes, Francisco.
Could you go over PSNS again?
All right, PSNS is Parasympathetic Nervous System. Okay, so Parasympathetic Nervous System. Do you guys remember the nickname of the Parasympathetic Nervous System? Remember that, Morgan?
Fight or flight?
Nope. No. All right, that's the rest and digest. So sympathetic is fight or flight, and that shuts off your digestion, right? Shuts off digestion. But then we have the parasympathetic nervous system. That's the part called the rest and digest system. Does that make sense?
Yeah.
Okay. And that's the one that controls all of our digestion activity. That's what makes you tired, right? Makes you tired after you eat. All right, so after Thanksgiving this week, you guys have Thanksgiving dinner or lunch, whatever you guys do. You always want to like try and take a nap afterwards, right? It's not always the turkey. How many of you guys have like ham on Thanksgiving? All right, some of you guys have ham? Okay. All right, how many of you guys have like just a big giant chicken? No? How about a turducken? You guys know what I'm talking about? Yeah, all right.
We had it once.
Yeah?
It was different tasting, to say the least.
Yeah? Yeah. Yeah, I don't know. I've never had duck, but I hear you have to have a taste for it apparently. So either you really like it or really don't like it. Any of you guys eat duck? Never had it before? Yeah, yeah. My cousin, well, brother-in-law, they shoot duck all the time. So, yeah, I don't know. No, I never. The only birds that I ever really liked to eat were pheasants and quail. They tasted really good. I never got into duck. Yeah. How about you, Abby? No duck?
Mm-mm.
All right. All right. Now, when you look at the alimentary tract, there's 4 distinct layers that we see. We have the mucosa. All right, so the mucosa is the internal lining. Okay, so this is the lining. Now, because we're talking about a mucous membrane, okay, what do we normally find in mucous membranes? Why do we call it a mucous membrane? What do you think, Elena?
Because it helps prevent friction.
Well, what does?
Mucus.
The mucus. Okay, so mucus is the key, right? Now, do you guys remember the cells that produce mucus in the respiratory system?
Goblet cells.
Goblet cells. All right, I should have had that on the quiz, right? Now, when you look at mucosal lining, again, we have all kinds of goblet cells in here. So we see those again here in an alimentary tract. All right, so we have all these goblet cells. They produce mucus, and this mucus lubricates the lining of the alimentary tract, and it also helps to keep you from digesting yourself, really. Okay, so it protects you from digesting yourself with all of those enzymes and the acids that we produce. All right, now the second layer is called the submucosa. So first layer mucosa, second layer submucosa. Now the submucosa, this is where we find lots of nerves and blood vessels Okay, so nerves and blood vessels are found in the submucosal layer. Number 3 is the muscularis layer. Okay, we have the muscularis layer. And when we look at the muscle, the muscular layer, we have 2 layers. We have circular layer, number 1. Okay, that's number 1. And then number 2, part B there, is we have a longitudinal layer. Okay, so we have 2 layers. A circular layer on the inside and a longitudinal layer on the outside. Okay, now these are the 2 layers, this muscularis layer. These are the 2 layers that create peristalsis. Okay, so they contract simultaneously, and this produces that wave-like motion that propels the food from one point into the next. Now the 4th layer, number 4, is what we refer to as the serosa. Okay, so the serosa is the outer covering. Now this is only found in the GI tract. All right, so we only have a serosa in the gastrointestinal tract, in the GI tract. Okay, now that mucosa, let's just talk about the mucosa just a little bit. Okay, so we look at the mucosa. We have this mucosa starting in the oral cavity, so it starts in your mouth, and it goes all the way down to the anus. Now the mucosa has different jobs in different areas. Okay, so the mucosa in your mouth and your esophagus, it protects you against friction. Okay, it protects you against friction in those 2 areas because of the chewing and the swallowing process. In the stomach, we see a very, very thick mucus to protect you against the acid in the stomach. But then we get into the small and large intestines. The small and large intestines, the mucosa is much more porous, which allows for absorption to take place. Okay, so in this picture here on the side, it shows you absorption occurring. All right, but again, you only see that in the small intestine or in the large intestine. Okay, so in those 2 areas of the body, it's very porous. Okay, very porous, which allows absorption to occur. All right, so almost all absorption takes place in your small intestine. All right. Now, anatomy. Okay, so we just talked about these. Okay, so in the mouth and esophagus, it's protective. In the gastrointestinal tract, it's more for absorption. All right. We see those goblet cells in there, right? Very, very significant, right? Because they produce the mucus. Then we talked about the submucosa, the muscularis layer, and then the serosa. Now, in the gastrointestinal tract, so in your abdomen, okay, so think about your stomach and your intestines. They're found in your abdominal and pelvic cavities, right? Now, lining the abdominal pelvic cavity, we have another serous membrane known as your peritoneum. All right, so the peritoneum is the serous membrane in your abdominal pelvic cavities. Now, why do we have a serous membrane in your abdominal pelvic cavity? What does serous membranes do? Do you remember? Do you remember, Michaela?
Chest cavity providing fat friction.
Exactly. Same thing is going to be here, right? Serous membranes, okay, reduce friction. Now, it's not necessarily as obvious here in the abdominal and pelvic areas, but your stomach is moving, right, when you're churning and grinding up the food. Your intestines are moving a little bit, okay? Your large intestine moves, especially when you guys, defecate. And so there is movement here inside your abdominal and pelvic cavity. Plus, think about all the action that happens down here when you're ambulating, right? When you're walking or running. When you guys are running, stuff is rubbing against each other down here, right? And so we still need that reduction in friction in your abdominal pelvic area, just like you would see it in your chest cavity. Now, what were the other two serous membranes? What was the serous membrane around your heart? Remember that one, Jacob? The one around your heart? They all start with a P, if that helps. No? Andrew?
Pericardium.
Pericardium. Okay, what's the one around your lungs? Remember that one, Andrew? No, that's all right. Logan? Pleura. Okay, so they all start with P. So we have the pericardium around the heart, we have the pleura around the lungs, and then we have the peritoneum around the abdominal and pelvic organs. All right, so those all help to reduce friction. Now the peritoneum forms, as the peritoneum is wrapping around all of these organs, it helps to form some very unique structures, like the omentum. I'm not worried about the lesser omentum, but I do want you guys to remember about the greater omentum because it's so great to have. All right, so we have the greater omentum. Now the greater omentum is an apron. It's an apron of fat that covers your abdomen. Okay? It's like a big apron of fat that kind of lies right over the top of the abdomen. Okay? Now, everybody has a greater omentum. Some are greater than others, though. Right, Molly? Do you know anybody who has a pretty great omentum? They have a rather distended abdomen, right? Saw this young dude this morning. And typically, I don't necessarily care about that, but he was a young guy. He was probably like 25 or 26. And man alive, did he have a huge beer belly. And just a huge, I mean, it was big. I'm like, dude, you're only like 26 years old. What happens when you're like 50? You're going to be dead, you know? And I didn't say that to him, but I'm like, man. I'm like, dude, man. But when this greater omentum gets thick, that's what causes that kind of like that paunch or that beer belly. Now, have you guys never noticed that it's not jiggly? You ever notice that? It's like hard as a rock. Okay? And it's because this is internal fat. So when someone has internal fat, it's very physiologically hazardous because it means that the body is struggling to deal with the person's diet. Okay, so typically when someone has a large greater omentum, okay, we always call it the beer belly, right? But there's a lot of guys that drink beer and don't have this big gut. Typically it's something else that they're eating a lot of that causes this to happen. Now, it might be a little bit genetic, okay, to the idea that their body handles food differently than other people's bodies. Does that make sense? Okay, now it's never genetic that someone just has to have a greater omentum, a big one like that. But the genetic idea or the understanding comes in is that maybe this person metabolizes food differently. And it just, for some reason, the body stores more of it inside that greater omentum. Okay? But what it does mean, no matter who has it, what it means, though, is that your cholesterol levels are skyrocketing. You're going to end up with coronary artery disease, and your liver is probably going to fail at some point. Okay? That's what it means to someone who has that really big greater omentum. Now, you know, I know a lot of guys, because I grew up on a farm, so almost all of the older farmer guys had, you know, greater omentums. Some dudes just had a really great one, you know. They'd always laugh about it. You know, they'd ask about it. They'd like, hey, it's my gas tank for my little machine. Oh, so that was, you guys didn't think that was funny. Maybe a little bit, yeah. Gas tank for the love machine, I don't know. You ever hear that? No?
We always say it's the boiler for hitting softball.
Oh, there you go, the boiler, there you go. Yeah, get that momentum going,
Yeah,
right?
that big inertia.
Momentum. All right. Now, another couple structures to make note of is the mesentery and the mesocolon. Now, these are layers of tissue that hold your small intestine and large intestine in place. All right, let me show you what that looks like on the next slide. All right, so here's a slide where we do a mid-sagittal cut. So a mid-sagittal view of your small intestine, or your abdominal pelvic cavity. We can see this stuff here holding your small intestine in place. Okay, so this stuff right here, all right, these kind of strips of material, we call it the mesentery. So that holds your small intestine in place. Now, the reason that this is significant is because you have 10 to 12 feet of small intestine. Okay, so the average person has 10 to 12 feet of small intestine. That's from me to Francisco away. All right, that's a lot of small intestine, right? You would think it would get twisted up, right? Get all twisted up. But it doesn't. The mesentery holds it in place in like folds or layers, like layer upon layer upon layer. And it keeps it from getting all twisted up. And that's really important because you don't want a twisted gut. That's extremely painful and you have to have surgery to get it fixed. Have you guys had like a horse or any like large animal that had a twisted gut? It's not good, right? They don't feel so hot. And so you got to get the vet in there and they have to cut it open and untwist it and kind of get the gas out of it and all that kind of stuff, right? Yeah, it is interesting. But man alive, I don't think that cow or horse or whatever else is really having all that much fun. All right, now, the other part is the mesocolon. The mesocolon. So that holds your large intestine in place. So here's like a little strip right here. All right, we call it mesocolon. You have 4 to 6 feet. You have 4 to 6 feet of large intestine, kind of wrapping around the outside edges of your abdominal and pelvic cavities. And you don't want that to get all twisted up, right? Because you get impacted and you get, a lot of pain, lots and lots and lots of pain. Okay, so those are other membranes or other structures produced by peritoneum. Mesentery, which holds your small intestine in place, mesocolon, which holds your large intestine in place, and there's just some structures to pay attention to. All right, here's what it looks like if you opened up the abdomen from the front. Okay, so if we looked at the cadaver, this is basically what you would see. Okay, so here's that big apron. Okay, so here's that big apron of fat that kind of drapes across the abdomen. Here it's kind of folded up over the chest cavity to kind of show you the mesocolon. Okay, so here's the mesocolon and down here is the mesentery. All right, so it looks like that kind of membrane in there. Now it is yellowish, right? Because typically it's full of fat. Now we'll look at another picture of the colon. It's very interesting. When we open up cadavers, it's always interesting to see how much fat they have on the inside. We had this one guy who had a really distended abdomen, and I'm like, man, we're going to get to see a great, big, greater omentum, right? Be able to pull that out and show the kids and everybody. And when we opened him up, he didn't have a great, big, greater omentum. I'm like, man. But he did have liver cancer. They don't tell us all that stuff, But he had liver cancer, and his liver was about 200% larger than it was supposed to be. Right, so it's like 2 or 3 times as big as it's supposed to be. It took almost all of his entire abdominal cavity up. So I felt really bad. I'm like, greater omentum, oh, liver cancer, man. Logan.
Greater omentum, is that behind or in front of the abdominal muscles?
It's behind the muscles, but it's in front of the intestines. Yep.
You know who Brock Lesnar is?
Yeah.
You see how his gut is?
Yeah.
Like you can see his abs, but his gut like protrudes out really far. That's why. I'm assuming?
Probably not.
Oh.
Okay. a lot of times when we look at, big guys like bodybuilders or anything like that, they've got like a protruding abdomen.
Yeah.
You ever notice that?
Yeah.
Now they're really muscular, but they got a protruding abdomen. There's a few different theories on that. I'm going to talk about one of them that is probably the most common theory, or at least the most substantial theory. Other theories is that they overtrain their abdominal muscles. Okay, so you do you do all kinds of weights and make your abdominal muscles really thick, but sometimes that can cause that action. But usually it's something with the intestines. Not necessarily a great omentum, but usually something in the intestines that we're going to talk about. Okay. Any other questions you guys have? All right. That guy's a beast, eh? Man alive.
Yeah, his tattoo's stupid though.
What does this tattoo say?
It's just a big, like, knife.
Like a sword going on? Oh, it's like a sword or something like that, right? No?
Yeah, I don't know, it's really dumb.
Yeah. I dare you to tell him that.
I feel like
yeah,
I feel like half his
he's
muscle is
more skinny.
steroids.
What's that, sir?
I feel like half his muscle is all steroids.
Maybe.
Oh, yeah, he got caught for steroids.
Yeah, he got
Or
kicked out of the UFC, right? Because of that?
he got suspended for like a year. I
Yeah.
think it was 6 months.
Mouth?
When do you usually do that? Is that like an advanced anatomy?
General and advanced, yeah. Yep, general and advanced. If you guys want to see him towards the end of the semester, I'll go take you guys in there and show you. Okay? Yeah, I'll totally do that for you guys. All right. So yeah, when you look at most wrestlers are all doing roids.
Oh yeah, they're all on roids.
Yeah.
All of them.
They had,
Even like The Rock and like John Cena and stuff.
Mhm.
I don't think they're on roids.
they've all admitted it,
But I
yeah.
think they're doing tests and like HGH and stuff like that.
Yeah.
Like they're doing some sort of pro hormone.
Yeah, they're probably all doing that to a certain degree. It's almost impossible to get that big. I mean, when you look at bodybuilders, pretty much every bodybuilder's on it.
Oh yeah.
You just can't get that big without it.
Even the
you know?
natural guys, they'll run it until like 3 weeks before the competition, so that's out of their system. So whenever they take the piss test or whatever test they take, it's not in there.
Oh yeah, yeah, yeah. I mean, I've got a friend who does all natural bodybuilding, but he's like in his 50s, so he's like in the senior category. I mean, when the guys are natural bodybuilders, they're muscular, but they're not huge. They look like muscular guys with no body fat, right? A friend of mine, his cousin thought about becoming a wrestler, so he was like, he went and started practicing with these guys. Man, he was so sore, and they're all these guys are like laughing at him. He's like, "Why are you laughing?" It's like they all do roids to recover. I mean, you can't bash somebody over the back with a metal chair, and you know what I'm saying, or throw somebody off the top rope onto a folding table without getting hurt. Really, I mean, seriously. So they all do roids, every one of them, even in the ones that we see around here in the bars over hunting season. All those guys are on roids. Yeah.
You can usually tell because if you look at like their chest, a lot of them have gyno of some sort of gyno, like a small case or big case.
Yeah, usually, yeah, you have gynecomastia, but that's typically when they stop. It gets really bad when they stop.
Yeah.
Yeah. Do you guys understand what he's talking about? It's like breast development in the male.
It's a fatty tissue that builds up on like underneath the pec, so it looks like a circle on my breast and stuff.
Doesn't it also cause like the hormones to?
Oh, absolutely, yeah. Yeah, if you ever want to know if a guy's on roids, just look at his testes, right? Can't find them, pretty much. They're like raisins. Yeah.
So a couple of people I talked to, they knew people that did steroids, and they would have to get like hormone injection shots and stuff like that.
Yeah, yeah. If it's medicinal necessity, I mean that's one thing, but most guys aren't that way. All right. What were we talking about again? Oh yeah, great omentum. All right. Okay. All right. Let's just talk a little bit about the oral cavity. We'll go through the oral cavity and we'll take a break. Okay. So when we look at the oral cavity, we have the muscles around the face that are responsible for mastication. I'm going to give you these muscles because we didn't really go through a lot of these in the muscular chapter. So we have this one muscle here called the masseter. All right, so the masseter is the main muscle of mastication. Okay, so the masseter. Now the masseter is the one on the side of your jaw. All right, when you watch somebody chew and kind of like the sides of their jaws kind of bulge out when they're biting down. All right, so that's what we call your masseter. Now I like to call it mass eater, right? The mass eater. Yeah, eating that today? You betcha. All right. Okay, so the mass eater is the one that helps us chew our food. Now it's very obvious in some dogs. You guys ever see a pit bull? Right, or a bulldog, you have these big muscular cheeks. That's the masseter in their jaw musculature. Okay? All right, that's the masseter, that big muscle that helps you bite down. Now, when we look at the oral cavity, this is where we see mastication. Okay, we chew up the food, we break it down, and then we allow chemical digestion to take place. Now, we have these accessory organs, the teeth, the tongue, and the salivary glands. These are all accessory organs which help with mastication or chemical digestion. All right, so the tongue, ounce for ounce, the tongue is the strongest muscle in the body. Okay? All right, now the largest and strongest muscle in the body is your gluteus maximus. Anybody know what that is? Your butt muscle? Okay, your butt muscle is the strongest muscle in the body, but it's because it's the biggest. If your tongue was as big as your butt, it would lick it every time. Did you get that? All right, get licked. All right, take a licking. All right. So ounce for ounce, this tongue is the strongest muscle in the body. Now the tongue helps to taste, right? It's responsible for taste. It helps you with chewing and swallowing as well. Okay, so taste, chewing or mastication, swallowing or deglutition. All right, so these are all functions of your tongue. Now, obviously, your teeth are for mastication. All right, without your teeth, you would not be able to grind up the food. All right, my oldest son just received braces this week. It was his birthday present. Just kidding. All right, but he got braces on Wednesday, and his teeth are really sore. How many of you guys had braces? Any of you guys had braces? Yeah. All right. Is it typically normal for your teeth to be really sore, so you can't like really chew very well the first? How many days? Like the first week?
I couldn't eat anything for the first week. It was like applesauce and Jello and ice cream.
Okay.
Lots of cold stuff.
Yeah. All right.
Lots of hot stuff.
All right. So
And then every time you get your bands changed.
that kind of hurts too.
It hurts.
Hurts a lot too. Yeah. Yeah.
I always wanted braces.
You always wanted braces?
No, you didn't.
Oh well, hey. No.
How's that straight?
Honestly, I would think about getting braces at my age even, because my teeth are shifting and all that kind of stuff. It's just, I don't know if they do retainers anymore. I don't know. I'll have to ask.
Like the Invisalign.
Oh yeah?
Yeah.
I'll have to see. I'll have to see if that works out. All right. So teeth. Now around your teeth, we have this mucosa called the gingiva. Okay, that's your gum, right? Your gums, your gingiva, your gums. Now, did you know your gingiva is extremely important to your health, even your heart? Do you guys know that? That your gingiva can affect your heart? You shake your head, Andrew. Can you tell us why?
I don't know why, but I was going to like the leader of heart disease was like gingivitis, or gingivitis caused heart disease.
Yeah, yeah. You guys remember those commercials that were on? I don't know if they still run them, but every once in a while, like this dentist will show up and say, "You're doing a great job taking care of your muscles, but what about your heart?" And the guy's like, "Well, yeah, of course I'm doing that." He's like, "No, you got cavities." When you look at the gingiva, if you get gingivitis or if you have cavities, that can lead to a very serious infection that can affect your heart and cause heart disease. Now in America, it's not necessarily as common as other parts of the world. Other parts of the world, 60% of the population will be affected by that, where they have cavities or problems with their mouth that lead to heart disease. In America, not so much because we have all kinds of antibiotics and stuff like that. It's very readily available, right? Just walk downstairs to the the free clinic and get some antibiotics if you want to. So there's a lot of that going on. Now, when we look at the teeth, okay, we have 20 baby teeth. All right, we have 20 deciduous or baby teeth. All right, 20 deciduous or what we call baby teeth. And then we have 32 permanent or what we call adult teeth. Okay, so about 20 baby teeth, and those fall out typically, and then your adult teeth come in. But this is a weird thing. When you look at teeth are very weird. How many of you guys still have baby teeth? Like maybe some of your premolars are still there? No, everybody's got theirs out? I've had a number of students that have still had like one or two of their baby teeth still left in there. Or how many of you guys have only like 2 of your wisdom teeth? Only 2 of them came in? What's that? None of yours came in? None of it all? Yeah? Well, that's good because you never had them pulled out.
I only got 3 of mine taken out.
You still got 1 left or it never came in?
It's left, it just moved.
It never really moved all that much, yeah? It's kind of weird, right? I've had students that they've had wisdom teeth taken out and then they've had a second set grow in. That's wicked. That's just terrible, right? That's torture.
Tooth grow in her front tooth. She had like an extra one.
Are you serious?
Yeah.
Yeah. Did she have to get it pulled out? Oh yeah, I would
She
take
said
that
it
sucker
hurt
right
worse
in.
than her wisdom teeth did.
Yeah.
Apparently really painful.
My younger brother had a tooth growing out of the roof of his mouth.
Ah.
It was just like an extra tooth, and they had to go in and remove it.
Yeah.
My-
It's really weird.
Yeah, my sister has like her mouth is crazy. She has like a tooth growing on her side of gums, like one over here,
Yeah.
like a couple down here.
Oh man.
It's like,
She's like a shark.
yeah, I know.
Just
Like-
pull those suckers out and new ones come in. Wow, that's got to be painful though. Yeah, kind of irritating, painful. But it's weird. It's just weird how the teeth just kind of, there's a standard, but then there's so many. It's actually very common to have all these different anomalies. All right. So your teeth. Okay, now the other accessory organs are these salivary glands. All right, we have 3 sets of salivary glands. You have these big parotid glands. Okay, there's the parotid gland. Okay, now here is the masseter. Okay, so you see this muscle right here on the side of the face? This guy right there, that's the masseter. All right, now we have these other salivary glands. We have this sublingual salivary gland just below your tongue. And then just below the mandible, we have these submandibular glands. All right, so sublingual salivary gland, submandibular salivary gland. All right, so these are the 3 sets of salivary glands. Now, these guys are very important because they produce lots of saliva. Now, is it better to produce lots of saliva or not much saliva? What do you think, Jess?
They're like constant. Can't you have problems if you have too much saliva? Or no?
Not really. Yeah, so obviously the answer is you want to produce a lot. Lots of saliva is good because it helps to clean your mouth. Saliva cleanses the mouth and it prevents bacterial growth. That's the reason right there that research shows that dogs have cleaner mouths than humans do. You guys have heard that before, right? Okay. Dogs have cleaner mouths than humans do. So how could that be true, right? If you guys have a dog, you know that dogs are not clean. They lick themselves, right? They eat poop. I mean, whatever it is, they'll eat it. Okay? So how can they have cleaner mouths than we do? And it's all about the saliva. They produce saliva constantly. And that saliva cleans their mouth of all the junk that they're ingesting. Now, okay, so we talked about these taste buds, okay? And then we have the salivary glands. Okay, so saliva cleans the mouth, cleans your palate, cleans your mouth. It helps to soften and compact your food into a bolus. It begins chemical digestion. Now I'm going to tell you the enzymes here. We have amylase, and that one's for starch. And then we have one called lipase, and that one's for fats. Okay? All right, so we have these enzymes in saliva. We have enzymes. One's for carbohydrates. We call that amylase. And then there's one for lipase, and that one's for fats. Now, the funny thing about amylase, because it's for starch, what are forms of starch?
Potatoes.
Potatoes, pasta,
White rice,
rice, yep, and
bread.
breads. Okay. Now, if you guys ever want to try this, you can. It's kind of interesting. If you take a cracker, okay, the more processed, the better. So if it's like a saltine, all right, that they work the best. Okay, so you put a saltine in your mouth, and don't masticate it, don't chew it up. Just let it sit there, and after about 90 seconds, if you can hold it there for 90 seconds, it'll start tasting sweet. It'll start tasting like sugar. Because carbohydrates or starch are all what? It's just basically sugar, right? And amylase breaks down the bread, it breaks down the cracker into glucose, and you start to taste that after about 90 seconds. That's interesting. Have you guys ever done that? Have you done that before? Yeah? All right. Try it over the weekend, right? Okay, so we produce about 1.5 liters of saliva a day. That's a lot, right? 1.5 liters of saliva. But again, like I said, it sounds gross, but it cleans your mouth, and it's good. All right, now teeth. We talked about the baby teeth and the adult teeth. Now, the tooth is covered with a substance called enamel. Enamel is the second hardest substance that is naturally occurring. Okay, so some of us have a lot of enamel on our teeth, and some of us have not as much enamel. The more enamel, the harder your tooth and the less cavities you probably have. If you have soft enamel or not as much enamel, you probably get cavities a lot. Okay, and that's just how much enamel your body produces. But the funny thing is that it's the second second hardest naturally occurring substance. What is the hardest naturally occurring substance? What do you think, Logan?
It's just a guess, but is it diamonds?
It is. Your teeth are second only to diamond. Isn't that crazy? That's pretty cool. Maybe we should put those on a ring. Here, honey. What's that?
I've seen a documentary about like somebody putting like their ring as like
Their eye tooth, yeah. Oh, that's kind of weird. But hey, it's really hard. It's never going anywhere, right? Just put it around a necklace, right? Like a shark tooth, or a bear tooth, or a lion's tooth, or something, exciting. I don't know. As long as it's not your baby teeth, right? Make a necklace of your baby teeth. That's gross. Okay. All right. So why don't we take a break, and then we'll finish it up here in the second lecture.